Hello everyone, welcome back to our channel, and today we are going to solve a classic LeetCode problem called TrueSum. This problem is quite frequently asked in interviews, and these will test your understanding of arrays as well as hash maps. So let's understand the problem statement first. So the problem statement says that you are given an array of integers, nums, okay? So this is your input and an integer target. So you are also given a target. So you'll have to return any two indexes which will add up to target. Okay. So you have to return indices of two numbers such that they add up to target. So out of these numbers, you have to return the index of two such number which will add up to target. Okay. So here you can see that 2 plus 7 results in 9. So the solution is 2 index is 0 and index of 7 is 1. So you may assume that each input would have exactly one solution. Okay. So there won't be multiple solutions. So each input array will hold only one pair which will result to that target. Okay. And you may not use the same element twice. So you'll have to use two different numbers. You can't use the same number, right? So here in example 2, you can't say that 3, you can't pick 3 and 3 and say that 3 plus 3 is 6, right? So you can't return the index of 3 as 0, 0. So both the index needs to be different. Okay. And you can return the answer in any order. So index 2 can be here and 1 can be here, or 1 can be here and 0 can be here. That's not a problem. Okay. So here if you see in the input, you are provided with 2, 7, 11, 15, right? So out of this 2 and 7 result in 9. So index of 2 is 0 and 7 is 1. So similarly 3 to 4, target is 6. So 2 plus 4 is 6, right? So index of 2 is 1 and 4 is 2. Okay. And similarly here 3, 3 and adding these two numbers will result in 6. So we are not picking same element, it's two different element, right? Both index are different. So it's 3 plus 3. Okay. So how to approach this problem? Okay. And let's look at the follow-up as well. It said that can you come up with an algorithm that is less than O of n square time complexity? Okay. So basically one brute force way to solve this problem is iterate, have two iteration. In first iteration, pick the first element and check for the rest of the element, that such that if there exists any element which will add up with the first element and will result in 9. And similarly, if there are none, then we'll start with the second element and then second element along with checking for the rest, like that, right? So basically we'll do like this, something like this. So for I will run till n, and inner loop will run from I plus 1, right, till n. So what we were doing is we'll pick this element and then check if there exists any other or the complement number which will result in 2 plus the complement number will result in 9. Okay. So we'll check it like this, and then if it doesn't result in it, then we'll take the 7 and then we'll check for 11 and 15, like that, right? So this time complexity of this time complexity is O of n square. So that's why they have asked for a follow-up saying that if there is any, if you can come, if there is any solution that is less than O of n square. Okay. So to solve this problem, there is also one more way using two pointer technique, like pointing the lower to the first element and higher to the last element, and then keep on decreasing our window till we found our, like, if but that solution would only work for a sorted input. Okay. So if our input was already a sorted element, then only that would work. It will not, because here we can see that our input doesn't have such criteria, right? Like saying that the input would be a sorted. It is an unsorted array, right? So here you see it's not 2 3 4 3 2 4, correct? So in such case, we will not be able to apply that problem because our result doesn't involve just returning the number. It involves returning the index. So even if we try to sort the input, it will try to sort the input. Then we'll lose the index of that number, right? Original index of that number. So we can't use that solution. So we'll have to come up with a better approach. So what we will do here is we'll make use of a hash map or dictionary in Python. Okay, so we'll make use of a hash map which will store the mapping of value to index. Okay, so this value has what index. Okay, so and we'll store a dictionary of number to index, and we'll keep on iterating for the number, and we'll see if the complementary number exists or not in that hash map. Because to check whether the number exists in a hash map or not, it's just O of 1, correct? So that would help us reduce our time complexity of the overall solution as well, and at the same time will not lose our the index information as well. Okay, so let's see what we are talking about. So for example, here, right, in this problem, our numbers are 2, 7, 11 and 15, and our target is 9, right? So our target is 9, correct? So here if you see, so we'll iterate one by one. Okay? So we'll iterate one by one. First we'll iterate to 2, and then it will go like this. And so each time we iterate, we also initialize a dictionary. Okay? So we'll also initialize a dictionary. Initially it will be an empty, and while iterating, it will see that whether the complementary number of 2 exists here or not. So by complementary, I am saying the another number which would result in 9 when adding with the current number. So 2 plus what number would result in 9? Okay, so 9 is our target. So here we see that 2, 9. So how will you get that number? By subtracting from the target, right? 9 minus 2 is 7. So we saw that 7 is not present here in dictionary. So if it is not present, then we'll just store this index values. So number is 2 and then index is 0. Okay. Now in a second iteration, it will point to 7, and we'll see that whether 9 minus 7 is 2, right? So 2 exists in the hash map or not? Yes, it does, right? So if it exists, then we have found our solution. So 7 is one number, and the other number is its complementary, which is present in our hash map. So we say that 7 and 2 result in 9, and 7th index is 1 and 2 index is 0. Okay, so that's how we do this problem. Let's code this solution. So initially we'll have a number to index dictionary. So we'll say num to index dictionary or a hash map. In Python we say it as dictionary, and we'll iterate over each element. We'll do this, like we'll have index as well as the number. Okay. Number for I num in inherit of nums. Okay. So each time we iterate, we'll find its complementary number. Complementary number would be target minus num, right? So 9 minus 2 meter. So target minus num. Now we will see that if this complementary number is present in our num to index dictionary or not. If it is present, then we have found a pair, right? So we'll return 2 pair first pair is the current index, that is I, okay, and second index is our so number 2 it will be here, right? So number 2 index dictionary of complementary, right? It's complementary number, okay. Or we can just sort it out, say comp is fine. So if the complementary is present in num2 index, then we have found. So the dictionary num2 index of the value com will hold the index. Else, if it is not found, then what? We'll just store that number to index in our dictionary. So we'll do it like this: num2 index of num is our index. So we'll store and we'll move forward. We'll check for the next number. Okay. So since it is said that it will have exactly one solution, so these will run at some point of time. So that's our solution. Let's run and check it. Perfect. Now let's try to submit. Amazing. Okay. So that's how we have successfully solved our two-sum problem. This will really help you in in your interview with array manipulation as well as using of hash map. If you have any doubt or if you have any suggestion, then you can write it in our comment box. If you really want to help us, then give us a thumbs up and hit the bell icon. Also, please subscribe to our channel for for similar videos. Thank you so much. Thanks a lot.